Hey guys, welcome to this video on confidence intervals for means. So what are we talking about when we're talking about confidence interval for means? Well, let's start by defining it and then look through an example. So a confidence interval for a population mean is an interval of values between two limits together with a percentage indicating our confidence that the mean lies in that interval. So what does this look like? So imagine for a moment that there's a claim that's been made about the protein or the mean protein content of a 1 litre carton of milk, and we're told that the mean protein content is 39 grams. However, we couldn't know this for certain unless we went and tested every single carton of milk, which, well, honestly is kind of an impossible task to do, and we would never have any milk to actually sell to the public because we'd be testing all of it, and when we test something and want to know the protein content, generally it's unfit for human consumption afterwards. However, we can draw reasonable conclusions from measuring the protein content of a random selection of cartons. So let's say that we just get a random selection of cartons and find that the mean protein content of the sample is 38 grams. Now, we said before that the mean content is claimed to be 39 grams, so there is a gram difference there. Now, we could say that, hang on a sec, well, our sample meant that found only 38 grams, not 39 grams. And we might go, well, that might be enough to dispute the claim. However, it's also possible that our sample that we got actually had a slightly lower protein content than what is normally out there, and the mean could still be 39 grams. This is where confidence intervals are really handy, because we can't tell from our sample with certainty that the exact population mean is definitely 39 grams. However, we can use it to predict an interval which we are confident that the population mean will lie, and this is what we call our confidence interval. So think for a moment about the statement. We are 95% confident that the mean protein content of milk cartons is between 37 and 40 grams. What this statement tells us is that the probability interval from 37 to 40 grams contains the population mean. We're going to say that the probability of that is 0.95 or 95%. And generally we use 95% for a lot of confidence intervals, because 95%, it's almost 100%. We can never say anything with 100% certainty. If we were to try to say it with 100% certainty, we'd have to measure every single thing. So, consider the population distribution where we've got x, n for the sample means of x with a line over the top of it. So it's sample mean line over the top. So if we have this as a sufficiently large enough value, we know that it's going to be normally distributed. We spoke about that previously when we were looking at the central limit theorem. What we're going to come up with is this formula here, where the sample mean minus 1.96 multiplied by the standard deviation divided by the square root of the number of samples is less than or equal to the mean, which is less than or equal to the mean plus 1.96 multiplied by the standard deviation divided by the square root of the number of samples. Now, where does this 1.96 come into it? Well, if we were to look at a normal distribution where our mean is 0, So looking at our Z distribution again, between minus A and A, we want to know what these values of A are. So this value of minus A and this value of plus A. Now, they're both going to be the same number, or the same value, just obviously with a minus sign in front of the first one, coming from left to right. If we work out the area of this blue part here to be 0.95, which is our 95% confidence interval, then the value of A is going to roughly be equal to 1.96. And that's where it comes from. That's where that 1.96 comes from. You could also rewrite this, if you wanted to, as x plus or minus 1.96 multiplied by the standard deviation divided by the number of samples, or the square root of the number of samples. What I want you guys to do is to get this written down, pause the video, get it written down, and then I'm going to write up another formula, which is the general confidence interval, where that means we could pick any number. So pause the video, get this written down. I'll see you in a moment. Alright, welcome back. So hopefully you've got that stuff written down. So let's look at a general confidence interval. So what this general confidence interval is, it's a generic formula that we can use for any confidence interval that we might want to know. So again, if we've got a normal distribution, the area shaded here in blue is 1 minus A, and that value of A is what we're going to use as our confidence interval. So for example, if we have looking for a 90% confidence interval, then we want A to be equal to 1 minus 0.9, in which case that'll give 0.1. That means that this Z of A on 2 value is going to be equal to 1.645, and we get that from technology. So that is just looking at a value, or trying to work out what the value of A there is. For example, if we want 98%, then A is just going to be 1 minus 0.98, which will give us 0.02. And again, that value for Z is, in this case, going to be equal to 2.326. And so on and so on. And we can find those out using technology, and I'll show you guys that in class. It's a bit easier to do it then. So it's still the exact same formula that we've used before, except instead of that 1.96, which for the value of 95%, which we've been using, A is just 0.05, so I think 1 take 0.95, 0.05, it's just 1.96 for the Z value there. So we can now use this to look at confidence intervals 90, 95, 98, 99, 80 if we really wanted to, but generally we're looking upwards of 90. And in fact, we might even go 99% most of the time. So we've also got a little bit of margin for error, which is just ZA on 2 multiplied by our standard deviation divided by the square root of our sample size. What I'm going to do in class is look at how we can then use this, or start to use this formula to see if, I'll show you guys how to do it on your calculators. It's good to know how to do it by hand, but we can also do it on our calculators. And in fact, why not, let's do one by hand. So get this stuff written down, and pause the video, get it written down. Then I'll look at a small example, in which case we'll then look at or further that example in class on how we would do that on our calculators. And I'll talk through some of the steps, the basic steps on what you would do in your calculator. So again, pause the video, get that written down. We'll see you in a moment. Alright, so welcome to this example. So I've got a sample of 60 yabbies taken from a dam. The sample mean weight of the yabbies is 84.6 grams. So number of yabbies, 60. The mean of those 60 yabbies is 84.6. We're given the population standard deviation as being 16.8 grams. What we're going to do is construct a 95% confidence interval for the population mean. So we've gotten this bit of information here, and we generally use C or C level. So C level, and that's what will actually show on your calculator as a C level, and we put that in as being 0.95. Again, this is out of 1, so your confidence level, you need to make sure you convert that to a decimal. Alright, let's plug these values into the formula that we've been looking at. So we're going to have 84.6, let's draw a better 6, take 1.96, because that's our value for 95% confidence interval, multiplied by 16.8 over the square root of 60. And again, just the same, except we're changing the sign there from minus to a positive. Now, if we plug this all into our calculator, I'm not expecting you guys to do this by hand, please use your calculator. We'll find that we're going to have 80.3 and 88.9. That means that we're 95% confident that the population mean lies between 80.3 grams and 88.9 grams. So it is a bit of a range there, but we're 95% confident that it's going to lie within that range. In fact, if we were to go to a 99% confidence interval, we'd find that it's actually smaller. So, what you do on your calculator is find the option or the little application or whichever part it is on your calculator that says Z interval. It might be on your calculator as one sample Z interval, but just general for Z interval. And what you're going to do for something like this, where we're given the data, we're going to make sure that our data is variable or stats, depending on the calculator that we're using. If it was data or a list, would it be putting in some values into our calculator in the form of a list, which I'll show you guys in class. So what we'd have is your options here are going to be putting in for your standard deviation, your sample mean, N for the number, and C level. So in this case, for each of these, we'd be putting in the standard deviation of 16.8, our sample mean of 84.6, our sample size of 60, and our C level or confidence level is 0.95. and we go calculate and let the calculator do its thing. It will generally show us either upper, lower, or left, right, or it might show us it in brackets. So Texas Instrument 1's goes 80.349, comma 88.851, whereas the Casio's, if you're using a older Casio, it will come up as left and right, in which case this is left and this is right. On the newer ones, it'll have lower and upper. What I'll also show you guys is how to do the list one on your calculators as well. So that's it for this video. I will show you guys there's a little bit more. I'll make a second part of this video. And if you've got any questions, just ask. As always, thanks for watching, and we'll see you next time.